about intermediate value theorem. The next piece that we're going to start looking at is how to decide if something is a zero of a polynomial without looking at a graph. So what other options do we have? And we will actually use synthetic division to do that. Do you guys remember doing synthetic division? Maybe the term sounds familiar.
I remember I failed the test. I feel like I remember not liking it.
Oh, usually people like synthetic. Let's start over then. Don't think back to previous times. We're going to start over with this really awesome thing called synthetic division. Okay, and we use that to divide polynomials. So if I gave you something like x squared minus 3x plus 4 divided by x minus 5. Okay, you could do long division to do that, or we can set up what's called synthetic division. Synthetic division is a shortcut where we are going to leave out any of the x's. So we start with what we're dividing by, x minus 5. What would make x minus 5 equal 0? Positive 5. So we're just going to put a positive 5 out here in this box. And then we are going to put the coefficients for what we are dividing by. No x's, just the coefficients. So coefficients, we said, are the numbers in front. So we had a 1x squared, a negative 3x, and a positive 4. Now, because we don't put the coefficient, or don't put the x's, you do have to watch. If you have missing powers of x, you have to put zeros for that. So if I had just x squared plus 4, you would do 1, 0, 4, because I didn't have any x to the first. So we'll touch on that with future problems. But now it's a series of multiplying and adding. The first digit just comes straight down. So I bring my 1 down. Skip a line in between here so we can come back and write. And then we're going to multiply and add. So 1 times 5. And then we add these things. So negative 3 plus 5.
2.
Multiply. 2 times 5. Add. 4 plus 10. 14. When you do this, the final number is always your remainder. This is your constant. This would be x. And the powers of x would just go up. If we have more numbers, the next one would be x squared, x cubed, and so forth. So when I write my answer, we have 1x plus 2 plus, when you have a remainder, you set that part up as a fraction. 14 over what we were originally dividing by. 14 over the x minus 5. So let's do another. Are there any questions on this one? So I want to divide 5x cubed minus 6x squared minus 28x plus 8 by x plus 2. Alright, so what goes out in the box?
Negative 2.
Negative 2. You take what you're dividing by and what would make that 0. And then we put our coefficients. So that would be a 5, negative 6, negative 28, and 8. Alright, skip a line. And we're going to do our synthetic. When you do this, the first number comes all the way down. So I bring that 5 all the way down. and then we just multiply and add. So 5 times negative 2 is negative 10. Add negative 6 plus negative 10 is negative 16. Multiply negative 2 times negative 16 is positive 32. Add, we get positive 4. Multiply 4 times negative 2 is negative 8. Add, and we get 0. So this 0 is my remainder. My constant, this will be an x squared. So my answer is 5x squared minus 16x plus 4. We have no remainder, so we don't have to put that. This one divided evenly. So far, so good? So in general, if it's a factor, that means it would divide evenly. So the remainder is 0. So anytime the remainder is 0, then that number is a factor. Right? We are going to talk a lot about factors versus 0. When I say factor, that's like x plus 3. The 0 would be what? It's like saying what makes x plus 3 equal 0? Negative 3. A factor has an x with it. A 0 is just a number. So if x minus 1 is a factor, what's the 0? 1. Okay. Another thing this factor theorem tells us. We can do the full synthetic division, and all we care about is the remainder, if it's 0. If you take the 0 and plug it into the original problem, what that gives you is the remainder from the division. Okay, that sounds a little confusing, so I'm going to do a couple examples and kind of show you what I'm talking about here. So first, if I want to know if something's a factor, there's essentially 2 ways of doing it. The first one is doing synthetic division. And if I'm doing synthetic division and I want it to be a factor, what am I looking for at the end? A 0. So let's do this one with synthetic division. If x minus 1, what would I put out in the box? 1. Okay, then my coefficients would be 2, negative 1, 2, negative 3. So the 2 comes straight down. Multiply, 2 times 1 is 2. Add, negative 1 plus 2 is 1. Multiply, 1 times 1 is 1. Add, 2 plus 1 is 3. Multiply, 1 times 3 is 3. Add, and we get 0. So is this a factor?
Yes.
All you have to look at is this right here. The remainder is 0, so it's a factor. Grab a calculator real quick, guys. I want you to find f of 1. So 1 is what we divide by. What happens if you just plug a 1 into this original problem for your x? So 2 times 1 cubed minus 1 squared. So what did it give you? 0. Where else did we see 0? Yeah. So there are 2 options. you can do the synthetic, or you can plug the number in, and it gives you the remainder. Okay, so if I wanted to check this one, if it was a factor, what could I do? Plug in what? Negative 2. You have to say, find the 0. Plug in the 0. What makes x plus 2 equal 0? That'd be negative 2. So if you plugged a negative 2 in, so 2 parentheses, negative 2 to the third, what do we get? What'd you get? Negative 27. So is this one a 0? No, because the remainder is 27. If you had done it with synthetic, you would do the negative 2 out in the box. So the number you plug in and the number you put in the box are the same. You wouldn't have to do both of these, you just pick one. But I'm just showing you that they are the same. We again get right here a remainder of negative 27. So there's a shortcut. If you don't need the full division, if you just want to know if it's a factor, you could just plug in the 0. I could ask the problem different ways. I might say, decide if negative 4 is a 0 of x to the 5th plus 12x squared minus 20. Okay, so you'll notice I didn't give it to you like a division problem. I just gave you the 0. So my two options, we know if I'm trying to decide if it's a 0, that's like saying, is it a factor? Does the remainder equal 0? Is really what I'm asking. So two options. I can do synthetic, or I can just plug in the number. If I'm just plugging in the number, I gave you the number. So all you would have to do is plug in negative 4. So if you plug in negative 4 into that, it's probably not going to be pretty because I just made that up. Wait, 52. You didn't get it. Let me see. Let's talk about how to do that one with synthetic. If I did synthetic, what number goes in the box? Negative 4. But what am I going to put for my coefficients?
0.
Yeah, I have a 1x to the 5th, I have 0x to the 4th, 0x cubed, 12x squared, 0x, and negative 20. So that one has a ton of zeros. And then we do our synthetic like usual. So the 1 comes down, multiply, get negative 4, add is negative 4. Multiply is 16, add is 16. Multiply negative 64, add negative 52. Multiply, so let's see, negative, or positive, sorry, 208. Multiply, so we get negative 832. Add and we get negative 852. So same thing, two different ways. All right. Are we okay on how I might ask this question? Whether I say, is x plus something a factor, or I might just say, is the number a 0? And either way, all I'm asking you to do is either plug in the number or do synthetic division and check your remainder. Let's look at this problem. Okay, so here is a polynomial. 2x cubed plus 5x squared minus x minus 6. Alright, so I want you to do a few things. We're going to try to connect some dots here. So I'm kind of trying to pull some stuff from the previous section with what we have right now and put it all together. So I want you to graph this and find the zeros. So grab your graphing calculator. We are going to plug that in. Sorry, I know I'm covering it up. Alright, so you get this. If I'm asking for the zeros on here, what am I asking for? Where it hits the x-axis. Okay, so we know this one and that one. So you're right. It was a degree 3, so we would expect 3 zeros. Remember we talked about multiplicities? When the graph bounces, that means this had a multiplicity of 2, so it was a 0 twice. So one of these is easy to tell. That's when x equals 1. Okay, so this, you're right, it's kind of hard to tell. Does that one go through and then come back, or is it hit and bounce? I can't really tell.
I thought it was 0.
Let me look. You're right. It doesn't hit and bounce. That one hits and comes back through. So you were correct there. Sorry. So this first one is where? -2, and then that one, what would maybe negative? What? What were you saying? -1.5. Okay. Alright, so what if I asked you to find the solutions to p of x equals 0? What am I asking? I'm asking, when is this equal 0? Isn't that the same thing as finding the zeros? So it's the same answer. I might ask these a few different ways.
Wait, where the negative 2 come from?
It hit here at -2. It's just really kind of hard to tell from mine. If I zoom in a little bit on my graph, it should make it better. So we hit the x-axis at -2, -1.5,
Makes sense.
and +1. Alright, so if 1 is a 0, what would the factor be? Remember I told you factors are when you put the x's with it. So that's saying 1 makes it 0, so the factor would have to be x minus 1. If -2 is a 0, the factor would be, I'm just asking you to list each of these. And if -1.5 is a 0, then it would be x plus 1.5. Good. Okay, so then the factored form, there I just listed the factors. The factored form is just when these things are multiplied. The only reason I asked the question this way is because the Math Excel assignment, there's one question where it does have you list them first. So just putting commas between them, and then the actual factored form is when it's all multiplied together. Can you guys tell me on this graph where the polynomial is greater than 0. So greater than 0 means it's above the axis, right? So it's above right here and right here. So if you want an interval, this one starts at -2 and ends at 1.5. We didn't want equal to, so they just get parentheses. And this one starts at 1 and goes to infinity. Good. Okay. Questions, sir? We're going to do 1 or 2 more examples and then I will stop for today. So our goal, the reason we're doing all this is because ultimately we want to be able to factor polynomials. So we know how to do factoring if we have like a quadratic where we can do box method or something like that. We are trying to get to factor higher level polynomials. So this one we're going to factor, but I'm giving you a starting point. I am going to tell you that 5 is one of the zeros of the polynomial. We need to get the complete factored form from that. So what we will do, if I give you the first 0, we are going to start by doing synthetic division with that first 0. So I know you can graph these and tell. The reason I am not solely relying on that is because if I give you ugly ones, that doesn't work, or if we had an imaginary number come up, our graph isn't going to show us that. So I encourage you to use the graph to double check yourself at the end, but you won't be able to solely rely on that to do these problems. So we'll start by dividing by 5, so my coefficients are 6, -37, 32, and 50. Now I've already told you that 5 is a 0, so that means when I do this synthetic, I should get 0. If I get anything else, I have made a mistake. So 6 comes down, multiplies to positive 30, add to negative 7. Multiply negative 35, add to negative 3. Multiply negative 15 and add to 0. Okay, so this is my remainder, my constant, this is my x and x squared. So we get 6x squared minus 7x minus 3. My goal was to factor this. Can I factor this part? Quadratic, we could do box method, right? We can't do shortcut.
That's what I was thinking.
Yeah. So we'll have to do the full box. So they need to multiply to negative 18, add to negative 7. So what numbers? Multiply to negative 18 and add to negative 7. Negative 9, positive 2. So it's 3x and 1, 2x minus 3. Alright, we are really, really close to done. This was originally an x to the 3rd. That tells me it has 3 zeros. I'm expecting 3 parentheses. I only have 2. Where is my 3rd one going to come from? The 5. If 5 is a 0, what would be my factor? X minus 5. And we just successfully factored that polynomial. What if I had said find the remaining zeros? I gave you the first 0 of 5. What would be the others?
-1.
You'd have to take those parentheses and set them equal to 0. So you would get a -1/3 and a +3/2. So whether I'm asking you for the zeros or the factored form, you really have to do the same thing. We have to factor it first in order to get the zeros. A 0 is just a number. A factor has an x with it. So really, the same question, just a couple different ways of writing that answer. Okay. Questions there? One more of these and then we stop. Is that okay? I don't want you to feel like I'm wasting your time and not teaching you everything you want to learn. I don't want to let you guys down.
I've learned everything I needed to learn my last time.
So what do we do first here?
Do synthetic.
What goes out in the box? So 6 comes down. 6 times -3 is -18. 19 plus -18 is 1. 1 times -3 is -3. 2 plus -3 is -1. -1 times -3 is +3. And that adds to 0. So this is my remainder constant x and x squared. So 6x squared plus x minus 1. So what do we need to do now? Got to factor that, so it's not a 1x squared, we have to do the full box. So multiply to -6, add to +1.
-2 and 3.
So then if we factor, we get 3x minus 1. So it would be a 2x plus 1. Yes, and since we had this -3 up here, -3 makes it equal 0, so we have to put x plus 3 for our final factored form. Okay, so that's my stopping point. What I want you to do is finish that math Excel assignment that I opened on Friday.